Okay, so I think this is where we left off yesterday. This is the slide we left off on yesterday. So Tyler, we did take notes yesterday, so you want to get those from somebody, or yeah, and Hong, you too, you'll want to get those from somebody. I recorded yesterday's lecture and put it in Schoology, so you can also watch that if you want to. Whichever way you want to do that, it's fine with me. Yeah, okay. So units and dimensions, we left off yesterday talking about how a unit is the actual unit of measure, whereas dimension, we're talking about things like it being either length or mass or time. That is your dimension. The unit is what you're actually measuring it in, like grams or kilograms or meters or seconds, okay? So actually, I think we can go past that. Don't worry about copying this down. That's not that important. Yeah, we talked about this yesterday. I didn't get to. And we said yesterday you need to make sure you know prefixes mega to micro. And that table that you just saw is in your textbook. I don't know what page it's on, but it's in there. We talked about that yesterday, and that.
Where's that noise?
I don't know. I know. I thought for a minute I was going crazy.
Is it that phone? What does the red light mean?
It means I have a missed call, but
Maybe it's the Michael.
every time I've called up there to see what my missed call was, she's like, "Hey, Chloe." So today we're going to talk about. We said yesterday. Let's go back this way. We said yesterday that in physics, when we do a math problem, because math is going to be all through here, that our dimensions have to be consistent. So if in an equation, both sides of the equation when we're done have to have the same units. You can't just stuff in numbers and work out the equation like you do math. You've got to have a unit that goes with it, and your units have to be consistent, okay? So if we have this formula, for example, it's a formula for determining your final displacement or your final distance away from something. So final distance is equal to the initial distance or initially where you started plus your velocity times your time. When you put all the units in there, they have to wind up coming out to be the same unit all the way across. So VF is length, VI is length, because those are both distances. V is length divided by time, that's our velocity, and then time, of course, is time. So when we do that, time cancels because you got time on the top, time on the bottom, so they cancel out. And that means we have length all the way across, which is what is supposed to happen. So if you're doing a calculation and that doesn't happen, then you have used the wrong formula. Okay? So you got to have them all come out to be the same dimension. Okay? And that's from yesterday. Okay? So today we're going to look at changing units. This type of calculation, one written in terms of dimension, refers to as dimensional analysis. So when we talk about changing units, changing back and forth, that's what we call dimensional analysis, where we can change from one unit into a different unit. Okay? So let's back it out here. Calculation written in terms of dimensions is what we call dimensional analysis. Okay? A lot of times we have to convert from a non-SI unit to an SI unit. Well, what in the world is an SI unit? SI unit just means the metric system. It's the system we use in science. We don't use feet and inches and pounds in science. We use the metric system. So sometimes you're going to have to convert between those two. That takes dimensional analysis. So here's an example. So if you want to jot this example down, you'd like to convert 316 feet to its equivalent in meters. So we look for a conversion factor. You'll find that 1 meter is approximately 3.28 feet. And then we just set up our dimensional analysis. So when you make the little ratio, because that's what this is, your dimensional analysis is where we make a ratio equal to 1. So 1 meter is 3.28 feet. So we can set up that ratio, and that's the same thing as multiplying by 1. So here's our railroad tracks is what we called it. They may look a little bit different, but 316 feet, and we put feet on the bottom. Why do we put feet on the bottom? So they cancel out. So we put what we want to cancel out on the bottom of our railroad track, what we want to get on the top. So we know that 1 meter is 3.28 feet. Oh, I'm sorry, I did not mean to clear that. Sorry. I will write that over. There we go. Feet. 3.28 feet over 1 meter. Feet cancel out, so we're just going to take 316 and we're going to divide by 3.28. That's it. That's all there is to it. Big deal. Okay? So if we have our calculator and we divide that out, we get 96.3 meters. All right, so I'm going to stop right here and jump ahead just a minute and talk about significant figures. We mentioned significant figures in chemistry last year, but we didn't focus on them a whole lot. In physics, we tend to focus on them a lot more. Okay? We just focus on them a little bit more. So significant figures says that your answer cannot be more accurate than the measurements you took to start with. Okay? So we measured 316, we measured that out to the ones place, to feet. All right? So how many significant figures are in the number 316? 3. The 3, the 1, and the 6. Okay? We do not really count conversions when we're doing these. Well, actually, I take that back. That's wrong. That's incorrect. If it's a conversion between meters and feet, between SI units and non-SI units, we do need to count significant figures in that measurement because that's an estimate. There are not exactly 3.28 feet in a meter. It's just an estimate. So how many significant figures would be in 3.28? 3. So how many significant figures should be in my answer? 3. Which is why we rounded to 96.3. You do it on your calculator, you get 96.34146341. Okay? But to keep it at 3 significant figures, we round it to 3. Okay, I'm going to open this door to see if it's in here or out there. Some weird thing on my phone? Okay, so that's dimensional analysis. Any questions on that so far? Has everybody got that written down? Okay. So math is the language of physics. We're going to do a lot of math in here, okay? So just kind of get ready for that. Like I was saying the other day, it's nothing past algebra 2 with trig. If you know your trig functions, you know algebra 2, you know just a smidge of geometry, you're fine, okay? Now, if you get to college and take physics, then we might get into some pre-cal and some calculus and all that, which... So, in general, the equation is a mathematical expression that relates to physics quantities. So, we're going to have lots of equations And basically that's all we're going to be doing is solving those equations. And like I said yesterday, you're going to have to pick out which equation goes with your particular problem. Okay? All right. Moving on from there. Oh, that was craziness. All right, so I think we're gonna stop there for right now. And we're gonna do, yes, sir?
So, all these like equations, do we have to remember them, or are we gonna have like a cheat sheet?
I haven't decided that yet.
Okay.
I probably will make you memorize some of them. When we get into vector problems, because some of those equations get pretty long, especially with all the sine and the cosine and all that kind of stuff, I may give you a cheat sheet for those. But ones like for force equals mass times acceleration. I think we can remember that. So a few of the easier ones you're gonna have to memorize. Okay? All right. So dimensional analysis, we're going to do a little activity with that, and then I'm going to give you some time to work on some practice problems so we can just practice using this. So let's see. Peyton, why don't you come up here and work? Well, we'll do this. We'll do this in groups of two again. We'll do this in groups of two. Okay. And Peyton, you probably are going to remember this from last year because I think you did it last year. And if you were in chemistry, you probably remember it. Okay. So y'all can work together. I think. Here's your. You think it's the microwave?
I don't know.
It's like coming from this direction. I think
It's either one of these speakers or maybe some sort of a cap.
Give Mr. White. Mr. White. Do it. When you investigate, stop. It's constantly be looking.
Okay. You may have to have groups of.
Maybe something's running low on battery. Maybe it's that thing up there. Is that the Wi-Fi? Like
Dude, that thing is never long.
That's the router.
Maybe it's fire alarm thing then.
Are those the things that let you record?
Yeah.
Okay, so I'm gonna put the. Can I have that one card that I get? Yes. I'm gonna put this on the overhead because I only have one of these. So you will need your piece of paper. While y'all are working that, I'll see if I can find Mr. White and we can figure out what in the world this is. It's driving us insane. All right.
Okay, so this is a live thing. Are the rabbits dead? Oh.
Man, this is already way cooler than AP Bio.
Oh, now, come on. Question is it cooler than AP Chem?
I don't know about that.
Okay, wait, that's.
So you're admitting AP Chem is really, really cool then, right?
No,
Okay.
it was okay.
Let me stop while I'm ahead. All right. Yes.
I can't wait till we do it in college.
Yes, since none of us passed these.
Hey, I told y'all.